Hello everybody, 10.4 inscribed angles and polygons. Alright, so what do we got here? We got an inscribed angle. What is an inscribed angle? What is a central angle? What is an intercepted arc? Alright, so the central angle we've done, right? So ROP is the central angle here. The inscribed angle is choosing a coordinate on the circle and making an angle with that coordinate, right? So RQP, right, would be an inscribed angle, right? So it's inside the circle, and so it's an inscribed angle, right? And the intercepted arc. The arc is RP is the intercepted arc. So angle RQP intercepts with arc RP. And so this angle ROP that also intercepts with arc RP. Now, we've come to the conclusion that the central angle here is going to equal the degrees of the arc, right? So we got the degrees of the arc and degrees of the central angle are one and the same. All right. So how does the inscribed angle work here, right? So we have the inscribed angle. So here's the inscribed angle. Here's the intercepted arc. And what happens and what's the relationship between that angle and that arc, okay? And there's a little formula for here. So the measure of the inscribed angle is 1/2 the measure of the intercepted arc. So here's angle ADB, and this is going to equal half the measure of arc AB. Okay, cool. I'll take that, and let's see what that means. So find the angle of T. So here's angle T, right? So RTS is an inscribed angle. So RTS is 1/2 of arc RS, right? This is the intercepted arc. So which is 1/2 of 48, and half of 48 sometimes is 24. Alright, so no big deal. And so what's the measure of arc QR? So here's arc QR. Alright, so we got arc QR. So we know RS is 48. Okay. We know QRT is 50. So if this angle is 50, then this arc here, QT, is the inscribed arc. So we're going to go the opposite way. So this is going to equal 100 degrees, right? So the arc is half, or the angle is half the arc. So that means the arc is twice the angle, going the opposite way around. TR is the diameter, because it goes through the center there. So if this whole thing is 180, then this is 100, and that means this is 80, and that would finish the arc there of 180 degrees. So QR is 80 degrees there. Alright, so next example, find a measure of RS. Let's put that there in red. So arc RS, cool, we're looking for that one. And the measure of angle STR. So STR is this one right here. Okay, so STR and RS. So this is the inscribed angle, this is the intercepted arc. Alright, and they got like multiple triangles going on here and multiple lines going on here. But what's cool about this is, right, this is the arc I'm looking at, but if you notice, these lines make that arc, and so do, let's choose a different color, and so does this angle, also makes that arc, also intercepts the arc RS. So we have two inscribed angles. We have angle STR inscribed, intercepting with arc RS, and SUR also doing that. So SUR is given to us as 31 degrees, so this one has to be double that, so 62 degrees. Well, if this is 62 degrees, and this is the arc, and this is the inscribed angle, then this angle must also be 31 degrees. Alright, so we're using a common intercepted arc to find the angles of another angle there. Cool. Let's try on another one. So what does this say? If two inscribed angles of a circle intercept the same arc, then the angles are congruent. Cool. So not much work there. So I'm going back to this one, right? We showed that they're both congruent. They're both intercepting the same arc RS. Angle SUR intercepts RS. STR also intercepts RS. Therefore, they are congruent. Check. Got it. Find the measure of the angle. Alright, so measure of it. So given measure of angle E is 75, and and then find the measure of angle F. Cool. So here's F, the unknown. Alright, so I'm gonna highlight a few things here. Okay, so we got this is 75, this is 75, and I'm gonna highlight. That means this is the arc that we're talking about. Alright, so that intercepts that arc. So that arc is going to be 2 times 75 or 150 degrees, right? Based on our formula. And then, like, alright, cool. So that's from here to here, and well, look at that. This is also F. Angle F is also using that as the intercepted arc, so angle F is also going to be 75 degrees, right? Without even looking at that arc of 150. They both intersect on the same arc. So this is 75, and this is using the same arc there. So that's also 75. So I did a little more work than I needed to there. But no big deal. It's fun anyway. So we got 1 and 2 going to that same arc there. Alright, cool. See if there's anything a little more challenging here. Alright, so find the measure of the red arc or angle. Alright, so you got a little monitoring progress here. I would probably hit pause at this point and see if you bang these out on your own and go from there. Alright, so here's the intercepted arc, giving you the arc. So this angle is 45 degrees, so it's going to be half of that. Vice versa. I'm giving you the angle, and you have the angle measure. Therefore, the arc is going to be 76 degrees there. And then here you have Y. Let me use a different color here. We got ZYW. And that's also ZXW, therefore this angle is 72 degrees, and so is that angle there at 72 degrees, right? They're intercepting the same arc, therefore the same degree angle. Alright, cool. What else we got? Alright, so a polygon is an inscribed polygon when all the vertices lie in the circle. Cool. So vertice, 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 vertice. Cool. The circle that contains the vertices is a circumscribed circle. Cool. I got it. Little core concept there. So the circle that contains the vertices is a circumscribed circle, and a polygon is an inscribed polygon when all the vertices lie on the circle. Alright, check. The inscribed right triangle theorem. Alright, so if you have a right triangle, so if a right triangle is inscribed in a circle, okay, then the hypotenuse is the diameter. Makes sense, right? Because the intercepted arc is here, and if this is 90 degrees, then 90 times 2 is 180. And if it's 180, then AC has to be the diameter because it's half of the circle. And then the converse. If one side of a inscribed triangle is the diameter of the circle, then the triangle is a right triangle, right? So if you tell me it's 180, then that angle has to be half of that, which is 90. Nice. Inscribed quadrilateral theorem. Quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. Okay, so a quadrilateral can be inscribed in a circle if and only if its opposite angles, so E and G, are supplementary, meaning a total of, right, adding 2 angles and getting a total of 180, right? Okay, no problem. And if these two are 180, then these two are going to be not congruent, but also they're not congruent, but this angle, right, not congruent angle. So E and G would be 180, and then F and D would also be 180, and those are not congruent angles, okay? Alright, and what else we got? It can be, but not. So find the value of each variable, hit pause, try these out real quick and see what's up. Okay, so find the value of each variable here. So we got the 2x here. AQB is the diameter, which means that this whole thing is 180 degrees, which means that this angle here is 90 degrees. So then I can say 2x is equal to 90, divide by 2, and x is equal to 45. Alright, no problem there. And then the inscribed quadrilateral, right? The vertices are inside the circle, big deal. So that means that y plus 120 is supplementary, so y is equal to 60. And then z plus 80 is also supplementary, so z is equal to 100. Alright, no big deal. Where's the challenge? Come on, we need a little challenge for you guys. Constructing, we're going to leave the, definitely read these. These are fun to read. If you can figure it out, you can do it. I'm going to leave the constructing for you guys. If we have some time towards the end, we'll do it again. And then here's some more problems on there for you. Definitely read these problems. Actually, a pretty fun problem. I don't know if you think about this. So you have a camera view of 90 degrees field of vision. You want to photograph the front of a statue. You stand at a location in the front. You want to change the location. Where else can you stand so that it appears in the whole camera base there. Take a look. Take a try at it. The solution's online on your textbook, and go from there. It's a fun problem. I think you guys should try this on your own. Find the value of each one. All right, so not too bad. You have pause here, see if you can figure these out. Okay, so you have inscribed circles. This is the diameter here. So x hopefully can be, or x is the known piece here. So x is going to be using the inscribed arc of MK, which is 180 degrees. So therefore x is 90. So now you have x is 90, and y has to be 50 in order for all three of them to equal 180 degrees. Alright, those two got to be supplementary. So y, that's supposed to be a y there, but happened to be a 4. Alright, so you got y plus 68 equals 180. Y is equal to 112. Alright, once you subtract 180 from both sides, and then you got another one. And again, this is still quadrilateral, so x plus 82 is equal to 180. So x is equal to 98 there. Take away 100, take away 80. 2 more, get 98. Alright, and then what do you got here? You have, cool, so you got c, and this one is 2c minus 6, so 2c minus 6 is one angle, plus c, and then you got equal 180. So you get a little bit more of an equation here. So you got 3c is equal to 174 after I bring the 6 over. Divide by 3, c is equal to 5 and 8, and you're done. And then the other one here is 10x and 8x, which is 18x, and those two total 180, so x is equal to 10. Alright, no big deal. And then I'm sure you're going to go around to some practice problems here for 10.4. Alright, so a couple theorems here on 10.4. Alright, so think back and think about what you learned in these. We got inscribed angles, the intercepted arcs, intercepted arc theorem, two arcs, two angles intercept the same arc at congruent angles. We talked about inscribed polygons. The opposite angles must be 180 degrees, and if your angle is 90, then the arc has to be 180, or if your angle is a right angle, then the arc has to be 180, or vice versa. If the arc is equal to 180, then the has to be diameter. It's also equal to 90. All right, a couple core concepts in there. And that's it. That's all you need for 10.4. See you guys on do a little practice, and I'll see you guys for 10.5. Talk to you soon.